With the advent of science and telescopes, humans have looked deeper and deeper into the sky, gradually explaining more and more of the universe. Mauritian radio astronomer Nadim Uzair is part of the construction of the most powerful radio telescope in the world. With its headquarters in Cape Town and radio dishes in the remote Karoo Desert, the square-kilometre array will provide data to answer humankind's most fundamental questions about the universe. Where did it come from, and of what is it made?
I'm Nadim Uzair. I come from a small island, Mauritius, next to Madagascar in the Indian Ocean. I love the sea. It's so huge and so immense, just like the sky, and the universe is so big. I studied in Mauritius, did my honors in physics, my master's and my PhD in radio astronomy. I moved down to Cape Town as a commissioning scientist with the Square Kilometre Array South Africa project.
South Africa has been chosen to host most of the Square Kilometre Array telescope, and Nadim is part of the team setting it up.
This instrument that we are building, the radio telescope, is going to be the biggest in the world. And this will allow scientists to understand lots of things that we still don't know and we don't understand about our own universe.
This is the headquarters of the Square Kilometre Array in Cape Town. The radio dishes, far away in the desert, are controlled from here.
So if you look at South Africa, Cape Town is the tip here. So in the northern Cape, in the desert, in the Karoo Desert, around like 800 kilometers away from Cape Town, that's where the telescopes are.
SK is a very large international project to build the most sensitive radio telescope ever built. And it's been built as a radio telescope array. The name comes from the idea of having 1 square kilometre of collecting area. So if you added up all the collecting area of the different kinds of antennas together, added it up, you should come to roughly 1 square kilometre of collecting area. This great sensitivity allows us to probe very, very weak signals in the universe, going back to the very early part of the universe, and to track the evolution of the universe over time.
Nadim is working on the prototype of the SKA, consisting of 7 radio dishes called Cat-7. It's already observing radio signals, which Nadim is using for scientific research.
A galaxy consists of millions of stars, but this galaxy is very, very far away from us. It's not even like kilometers, it's not even 1,000 kilometers, it's at 1 trillion kilometers away from us. So it's like 40 with 18 zeros. That's how far this galaxy is from us. So this contour that you see has been done by taking the Cat-7 telescope and pointing for 12 hours on that region there and try to extract information, okay, basically in the radio regime, okay, from that source. So the green line here is the radio image which has been overlaid or superposed onto that. It's a spiral galaxy which is moving. And now what you see here is a distribution of neutron hydrogen. And then we scientists, what we do is we take this information and we are going to transfer that into more scientific meaning to us, and we make a color image like that. Now this color image shows you how this gas is moving with respect to the galaxy. Like the blue one is coming towards you and the red one is going away. So you can see that there is a rotation. This allows us to understand the rotation.
Nadim grew up in rural Mauritius, and after work likes to get back to nature by walking on Cape Town's mountains and reflecting on his amazing journey.
That time when we had this comet Halley, which was like crossing and was like so visible to the naked eye, and I remember like every day was just like, oh, that's a comet, you know. And then someone tells you like, hey, you know what? It's going after 75 years that you're going to see that, and you started counting like, wow, 75 years, wow, you know. And then okay, you start like putting notion of time and distances, and it's like you find that okay, the whole universe is so huge, and there's so many interesting things. So then the teacher asked me, okay, what do you want to do? I said, oh, I want to go and observe the stars and the comets and the planets and everything. Then he said, like, no, you should not do that because this is really difficult. I said, no, this is what I want to do, because if you're telling me it's difficult, okay, I love this challenge. And that's, okay, where I came into this field of radio astronomy. Cape Town and South Africa itself is huge. It's a huge place. It's so different, okay, as compared to Mauritius, because in Mauritius you just like drive around 2 or 3 hours and that's it. You are on the other side of the island. Whereas here you keep on driving and every time you just like take a random turn and you just like discover beautiful places around here. I love discovering new places and I love food.
Awesome. Thank you very much.
The SKA will provide opportunities for many African scientists. And the African Institute for Mathematical Sciences is helping educate many of the young mathematicians that will be needed.
Go ahead and run your program and make sure that it does what you want it to do.
There's already a group of postgraduate students busy with research that will benefit from data from the SKA.
Sure. So can you give us an update on what you're working on?
I've been trying to develop a new stacking technique specifically for when SKA comes online. We're looking at galaxies in the radio which are really faint, so you can't tell much from one galaxy, but if you stack them all together, you can pick out average properties of the galaxies out of the noise.
Okay. Okay, Patrice, give us an update on what you're working on.
In this paper, the question was, how flat is the universe? If you take a huge triangle, do you still have the sum of the three angles summing up to 180 degrees? That's the question we're asking in some way.
Until recently, scientists believed that all the material in the universe was stuff we could see and feel. But then it became clear that we only understand a fraction of what exists in the universe.
We are made up of matter. Anything around us, okay, is made up of matter. The sun is made up of matter. The sea, the rock, everything is made up of matter. If you take all these material which constitute those objects that we have in our universe, we have found that it's only 4% of what we know about the universe. 96% we don't know.
Nadim's friend and colleague, Bruce Bassett, is a South African cosmologist who works at the Maths Institute, AIMS. He is trying to explain the 96% of matter and energy in the universe, called dark matter and dark energy, that we don't understand.
You're a cosmologist. Can you tell me more about dark matter and dark energy?
Sure, well, there must be something else pulling those outer stars in a circle, allowing them to move very fast, which is what was one of the first signals for dark matter.
Because dark matter is invisible, scientists only know it's there from the effects it has on other things, like light.
The mass bends the path of light, just like a lens, and that bending cannot be explained with just the visible mass that we can see.
So it's just like a normal lens that
exactly.
If you have an object at the back, you have a lens, and then okay, you see an image. But what you're saying here is that there is an invisible mass in front.
Exactly.
And then by looking at the galaxies at the back, then okay, you have kind of like...
Exactly. So we look at the galaxies behind. As their light travels, there's something very massive that distorts this background image into long arcs. And then in 1998...
Similarly, dark energy can be presumed to exist by looking at exploding stars or supernovae,
as you know, supernovae are stars
which for a few weeks burn as brightly as 100 billion stars.
the weird thing about it was that they were dimmer than we expected. So because they're dimmer, it means that they're further away. Well, that's the simplest explanation. So looking at these distant supernovae, we realize the universe is speeding up, not slowing down. And that's really weird, since gravity sucks. So we expected it to be, universe to be slowing down, not speeding up.
So by observing those distant objects in the universe, we can build our knowledge, okay, on these topics like dark matter and dark energy.
SKA will provide data from the universe that theorists like Bruce need to make and test their theories.
As a commissioning scientist, what we do is we run experiment, scientific experiment, to test the telescope, making sure that everything is working fine from the hardware, that is from the telescope itself, to the software, and ensure that if tomorrow we give this instrument to other scientists, they will just be able to use it. So we also have to prepare documentation how to use this instrument. And I still don't understand if you like
the radio dishes are situated in the desert, where there is little interference from man-made radio waves, from things like radios, microwave ovens, and cell phones.
Thing about antenna 1. Yeah.
Therefore, signals from the individual radio dishes need to be closely monitored to ensure there is no interference disturbing the signals from the universe.
For the bandpass. But what are those spikes on antenna 1?
Oh, you're right, that seems a bit strange. There's some spike here coming up.
Unfortunately, that's not really something we can do from the control room in Cape Town. Can we send you to site tomorrow to sort this out?
Yeah, sure. We'll have to make a plan, and we'll drive up tomorrow and then try to find out, where it's coming from. So as we've been talking with Jasper, we've seen, there is some problem, with one of the antenna. We have seen those spikes. These are RFI. And these are signals, which will affect us because the signal we are looking are very, very weak. So these peak, they affect us.
Nadim invites Bruce on the trip to the SKA site, so he can see where new data for astronomers and cosmologists will come from.
We'll do the road trip together and try to talk a little bit more about dark matter, dark energy, and how the whole scientific community is going to benefit from this proudly South African project. And Bruce is a cosmologist, so he's going to be one of the users of these huge amount of data coming from the Meerkat.
So a cosmologist, I would say, someone who's interested in the universe as a single object, as if it was like a tennis ball. And we're interested in questions like, where did the universe come from? Where is it going to? Will it expand forever? Will it last forever? Did it start a finite time in the past, or has it always existed? So cosmology, in a sense, is very, very different from other parts of science in that sense. It's very holistic, very inclusive. The SKA will produce, one estimate is an exabyte of data every day, and African scientists will have to, with scientists from around the world, grapple with that amount of data. And it's clear that that is the future of humanity. We are moving towards being one planet united by information. SKA will be the tip of a spear that will penetrate into the 21st century and bring Africa, hopefully, along into being a first world continent.
The cutting edge of physics research intersects with philosophical and even religious questions.
But Bruce, just tell me, why should we be so special?
One of the interesting elements that the SKA is going to shed a lot of light on is this issue of whether we live at a special time in the history of the universe. Our standard model is that for most of the history of the universe, dark energy was actually negligible. It wasn't important. But roughly 5 billion years ago, roughly around the time the Earth was formed, the dark energy started to become important. And ever since then, the universe has been accelerating. Whereas before that, it was slowing down.
If you're saying like, hey, you know, we are waiting for you guys, okay, come on.
Exactly.
Get up, and then after that start.
It seems like this incredible coincidence that we as humans are around on this planet roughly, more or less, in cosmological timescales, at the time when the universe began to speed up. And that's very uncomfortable, because, you know, the idea that we are special is something that, you know, scientists don't like. And so, you know, that's one of the big issues that we need that the SK will really help resolve. I think cosmology, perhaps as much or even perhaps more than other sciences, is a very creative field. It's extremely philosophical, and by definition, these are big ideas. They're ideas that span, you know, the biggest kind of concepts one can have as a human being, almost. You know, to ask questions of why are we here? How do we give meaning to our existence? In some sense, cosmology is a very nice lens through which to address questions like that.
One of the remotest sites in South Africa, 800 kilometers from Cape Town, was chosen for the SKA site. Here, there is minimal man-made radio signal that can interfere with the radio waves from outer space. Carnarvon is the nearest town to the SKA site. The main industry is sheep farming. With the establishment of the SKA, the town is expected to grow. Outreach programs by SKA will improve the school science education and provide opportunities for the youth.
Looking forward to some good South African Karoo lamb.
So you're ready for your first experience, okay, with the Cat 7 tomorrow?
Yes, really good.
The first mankind, okay, coming from Africa, been also looking up in the sky.
Absolutely.
Fascinated, okay, by the stars, and start understanding, okay, what are these like bright objects?
This is a great analogy for dark matter, because we can see the flames, but above the flames there's still heat. So you might ask, how do we know that it's hot without putting your hand there?
Yeah.
And actually, you know, the shimmering that the heat causes of the background, of an image in the background, is very similar to how we detect dark matter with gravitational lensing.
So
the mass bends light, and we see, you know, the background image is distorted.
It's very similar to, like, you know, when we are driving on the road, you know, on like very hot days, and then okay, you look at the end of the road and you see like, okay, it's like
shimmering,
getting like
exactly,
diffuse and blurry.
Mirage, exactly. Mirage, yeah. So that's how we detect dark matter as well. Great. What do you think? Think that's ready? Almost. Yeah, I love that old San myth that the Milky Way was the backbone of God. Now we've replaced that myth with science, but it's still a very romantic image, I think.
For thousands of years in this area, the San, or Bushman hunter-gatherers, keenly observed the changing patterns in the sky. Their healing dance enabled shamans to go into trance, where they traveled to the spirit world and intervened on behalf of their community. They developed a rich cosmology that explained the heavens and their existence, which is reflected in the sacred images they engraved on the rocks.
So here we are, Bruce, after a long road trip, the Karoo Array Telescope.
Amazing. Wow.
So here we are.
Amazing.
Cat 7.
Beautiful.
Yeah, you can see. 1, 2, 3, 4, 5, 6, and 7 is at the back.
So what are the dishes actually made of?
It's fiberglass.
Wow, just like a surfboard.
Same thing, same material. Just like touch it. You won't believe it, just touch it.
It's amazing.
The first 7 radio dishes for the prototype Cat 7 were completed 2 years ago and are already generating scientific data. The telescope attains massive sensitivity by coupling numerous radio dishes together and adding the separate signals.
Just like an optical telescope, you have a small telescope, you see a little bit of the sky, you see some sources. Bigger one, you see much better. So here we have a dish. The dish is collecting those radio waves coming from space. The bigger you have, the more signal, okay, you can collect.
The more sensitive you
The
are.
more sensitive you become.
The further you can see, right?
Yeah. But now what happened is, you can't keep on building big and big telescope. With the SKA, we use this technique called interferometer. So what we do, we break that big telescope by putting smaller telescope and connecting all of them.
So Cat 7 is just an example of that, right? We have 7 telescopes, but the idea is that you can scale that to thousands of dishes.
As long as, okay, you want, you know.
The next phase of the telescope array is now under construction and will increase the number of radio dishes to 64. It's called the Meerkat and will be ready in 2018. The final phase is the International Square Kilometre Array, which will be ready in 2024. It will have about 3,000 radio dishes. Most will be here at Carnarvon, and the rest spread out over various parts of Africa.
In astronomy, okay, I can apply the laws of physics that I learned. I can see it's a huge laboratory, you know. You have galaxies which contains millions of stars. These galaxies, okay, they collide. The same like collision that we know. They collide, and then, okay, they form different types of morphology of galaxies. But now when you look at on bigger scale, galaxies, they are not alone in the universe. They stay in groups, in clusters. These clusters also interact. And this is like a perpetual, like, you know, interaction of science, okay, which is happening up there in the universe. So this is the biggest laboratory for me, and it's for free. It's just up there.
Meerkat and the SKA will revolutionize our understanding of the universe, and to be part of that is a wonderful privilege. It's an incredible privilege. And it's incredible to also look at these telescopes that are picking up signals that have traveled for hundreds of millions of years. They've crossed the universe to be picked up and captured, and which will give us the clues we need to unravel the mysteries of the universe.
Nadim investigates the problem of the interference spikes in Radio Dish 1's signal that he was sent to fix. He finds a faulty radio shield in the dish, which he is able to adjust.
Okay, guys, I just had a look at the plot, and I think, okay, the new results, okay, looks much better. All the RFI seems to have gone now.
To understand why we need dark matter, here's an analogy perhaps. Imagine this. Imagine you have a rock on a piece of rope and you swing it around. First, everything's fine, but then you start to swing it faster and faster. To keep the rock going in a circle, the string has to exert a stronger and stronger force because, you know, the rock's trying to get away. And so eventually the string will break and the rock will fly off. The same thing is happening with the stars in the galaxy. The galaxy is rotating, the stars are going around the center of the galaxy, just like we're going around the center of the Milky Way. And they're moving too fast for the gravitational field, which is in this analogy is the string, to hold them together. This dark matter provides the extra gravitational force to keep the stars going in a circle.
But then, okay, how about dark energy?
Well, dark energy we need for a completely different reason. Imagine that someone walks past you, and every 5 seconds or so, you turn around to look how far they've got. Every time you turn around, they've gone further than they did in the previous 5 seconds. So they're disappearing off into the distance. And that's exactly what we can do with exploding supernovae. We can measure their distances. And when we look back in time, these things are too far away if the universe was simply slowing down
Smoothly.
Yeah. So, in fact, the only way that we've come up with really explaining that in a way that people think makes sense is if the universe is actually speeding up, carrying these lighthouses further and further away in equal amounts of time, essentially.
Understanding dark matter and dark energy is very difficult, even for scientists. But as SKA produces more and more data, and more scientists work on it, answers will be found to these and many other questions about the universe. In fact, answers will also be found to questions scientists haven't even thought to ask yet.
SKA, in its final state, will measure hundreds of millions, if not billions, of galaxy positions, be able to map the universe like we have mapped Earth. We're just on the beginning of what's going to be an incredibly exciting adventure.
All of this will come from the instrument that we are going to build here on this African continent for the whole world to use, for the whole of humanity.